We are backtracking and talking about the Unit 3 mid-unit test. This was covering 7.1 to 8.1, and it's all about motion graphs. So this is all about motion graphs and rates. So let's take a look. In questions 1 through 5, circle the letter of the description that best matches the graph or table. Well, before I even read these, let's take a look at this. Distance from the ground floor and time. If it's distance from the ground floor, I know I'm dealing with the elevator. The elevator went up really slowly, so this is up slow, and then descended or down quickly. Now let's take a look. The elevator, the skater, the elevator. Well, it's definitely not about the skater. It's definitely not about the skater. So we're down to 2, and I haven't even read anything yet. So the elevator descended slowly and then rose quickly. Descended means down, rise means up. But this went up and then down, so that can't be it. The elevator rose slow, or went up slow, then descended down quickly, descended quickly. So D would be the right answer. Pause and write an explanation on your paper as to why you got that one right or why it needs to be corrected. Number 2. Distance from the motion detector, which means I'm dealing with the skateboard. I know I didn't move. Didn't move. A straight line means no movement whatsoever. So no movement. So let's take a look. Skated, stood still, skater. Okay, so it's all about skaters. Mike skated at a constant rate away. Away is up, so no. Mike skated slowly away. Away is up, so no. Mike stood still some distance in front of a motion detector. Stood still means no movement, so maybe. The graph cannot represent a skater's distance from a motion detector with respect to time. It absolutely can. It stood still, it didn't move. All right, next one. Distance from the motion detector. So again, we're dealing with the skater. Elevator, no. Skater, yes. Elevator, no. Skater, yes. Okay, so let's talk about this. It goes down or towards quickly and then away slowly. The skater skated down the ramp and then back up. Down the ramp and back up. Well, wait a minute. Down the ramp? Is he on a ramp? Is he going up a hill and then down a hill? No. The skater skated quickly towards the motion detector and then skated away slowly. Towards quickly, away slowly. D it is. All right, and the next one. Number 4. Let's talk about this. Motion detector, so I'm working with the skateboarder. What is my rate when it's up straight up? Well, we said it about 10 times in class. It's undefined, which means cannot happen. And here's why. Let's say this is 2 seconds. This is 1 foot, 2 feet, and 3 feet. In 2 seconds, at 2 seconds after I start, I can't be 1 foot away and at the same exact time 2 feet away and at the same exact time 3 feet away. I can't be at all those places at once. So this graph cannot represent a skater's distance from a motion because this is undefined. This cannot happen. I cannot be at 3 different places at one time. All right, remember, pause it, take a moment to write down what your mistake was or what you understand now. Okay, 5th one. Let's talk about time. So time's passing, distance. So I'm going down a floor, then I stay still. I went up 3 floors, I went up again, and then I went up again. So I was at the 3rd floor, then the 2nd floor, then I stayed at the 1st floor for 3 seconds, 1, 2, 3. I'm sorry, 2 seconds. 1, 2. And then I went back up. If I made a little bit of a graph of this, I started at the 3rd floor, went down to 2, went down to 1, stayed at 1, up to 4, up to 7, up to 10. So let's take a look. The elevator descended slowly, then paused, and rose quickly. Descended, paused, rose, maybe. The skater, well, wait a minute. This is ground floor, so there's definitely no skater. The elevator rose quickly, paused, and descended. Well, that can't be it because we went down, paused, then went back up. So it's got to be descended slowly, down, paused, rose means up. All right, in 6A, B, C, D, and E, you had to find the rates, okay? Each elevator moves at a constant rate. For each problem, find the rate of change. Remember that the rate of change is the change in Y over the change in X. Well, let's take a look at this. First off, my Y is distance in ground floors, so my Y is floors. My X is seconds.